Okay, so we're picking up on page 5 here, folks. Now this is when we're talking about, in particular, window and door families. So this is a bit of a parenthetical discussion. If you folks were to go to the, we're going to go to the session 5 folder tonight. And if you guys go to session 5, inside the session 5 folder, I've got a family called Splayed Opening. Splayed Opening. So just open it up, and this is what you will see on your screen. This is also the image you see on the top of page 5. Now this is perhaps an uncommon scenario, but you're going to know what to do now in case you run into this situation. This was a case where we were doing a window for a Catholic church, and they wanted, because they wanted a thick mass wall, like you've seen at Corbusier's church in France. I never know how to say it. How do you say Rochon? Because the P is silent, whatever it is. Yes?
Is this on the J drive?
It is. It's on a J drive. J, BLDG. Oh, you can open it. It might be opened by somebody else, but you can still open it. You folks should all be able to grab this from the J drive. J, BLDG 2805. It's on a share out folder.
J drive,
Share out. Yes. Share out BLDG 2805 session 5. Oh, okay. Well, don't worry about it. We'll get it to you later. All right. So, so here's the deal. So the clients have this thick wall. The design team, what they wanted to do was, with this thick wall, they wanted to splay the opening on the inside so it would allow more light into the sanctuary. And here, I'll pull it up here, so you guys can see what the intent was. So there you go. Thick wall. Didn't want to just use the regular window object because it just cuts the hole straight through, you know, only the size of the opening, but we wanted to make that opening larger. So when you start with the typical window template, the window template has an opening in it, but it is a straight cut. Right? So there's your window opening. It's a straight cut through the wall. So what we want to do is this. We want to be able to control the size of that opening. So what we ended up having to do was delete the window opening that used to be in the center of our window. And so what we've got here, folks, we've added some voids. So normally when you build a family, you use the voids to cut the solids that you've made. But in this case, what we've done is we've used voids to cut that piece of wall that's in the window template. So the void, after we've drawn it, is now cutting this little host wall that's in the window template. When you then bring this into your project, it does this cutout in any wall that you insert it into. So this allowed us to create that recess in the wall. So here what I'm going to do, so I'll make a new, again, don't try and do this, just watch up here and I'll show you that we're getting the effect that we wanted. So I'm loading this right here into my project. There we go. Look at 3D. There it is. So my window at this point doesn't have a frame or a glass. We're going to do that now, but you can see it is creating a splayed opening. Now the problem that we discovered is that as soon as we had a void that was cutting into the wall, Revit gives you an error. So here is the out-of-the-box window template. I'm just opening it up and showing you folks. So I'm going to do a void here. So this is just the problem. There's my void. And if we look at it in 3D, there's the void right there. So if I make this void, cut the bit of host wall that's there using the cut geometry command. So we're going to be working with this tool. Like Revit says, oh, you can't have an opening and a cut in the same host. So we're like, oh, so how do we make the hole through the wall for the actual window itself? So then we realized we had to have two voids. So there's two voids in this thing. There's a blend void, which starts at the opening that we want, which is just a simple extrusion void. So there's that there. It's an extrusion void, the size of our window. So if you were to go into elevation in this family and find the little box in the middle, the little void that's cutting the hole through, it's a rectangle. It's exactly where the opening used to be, but this is the one that cuts the hole right through the wall for our window. That's void number one. The second void is this blend here. There it is. And remember that blends are made of two sketches, one at the bottom and one at the top, at either end of a blend. It's like an extrusion that over a linear distance changes from one shape on one end to a different shape at the other end. That is what a blend is. So those two voids create that shape that we want in the window. Now, the next thing to talk about here, and of course 95% if not more of your doors and windows, you'll just be able to use the opening object and you'll be fine. Next paragraph, building families around custom openings. If you're not just making a rectangular or circular window or door, so actually what I'll do here is I'll create a new door here, a new door template. Again, don't try and follow along. I just want to talk about the principle here of a custom opening. So right now, whenever you open up a door or window template using the out-of-the-box template for a door or a window, Revit has created an opening that's already there for you. Right? There's our opening. It's already there in the template. If the width parameter changes, it moves these two reference planes around. They stretch in or out. The opening is constrained or locked to these reference planes. So when the reference planes move around by virtue of the label on the dimension, or the value of the dimension changing, whether it's the width or the height, that's how the opening changes shape. But let's say that we want to have a door that has a side light beside it. Well, obviously, you want to cut an opening out of the wall for your side light. If your side light doesn't come all the way down to the floor, then what we need to do is edit the shape of the opening to incorporate that extra void on the side. So step one might be to go and find that void. There it is there. You can see I've got my cursor on the opening object. And this is just like the opening object in your project. If you've ever used the wall opening object, it's the same idea. So there's our pink lines. So what I need to do, see there's the pink lines there, just away from my my sketch line. So what I need to do, obviously, is to modify the opening sketch so that I include this side light that I want to add to my door. And then I just go and use the trim command to clean this up. So now when I'm done, my opening has changed. So if you're not adding, you know, special custom voids into your walls, then, you know, you just decide, hey, if it's not a rectangular opening, or if I need to add a funky shape, you need to do that by altering the opening first. So that's kind of one of the preliminary steps before you actually get started building your geometry, because once you've got the opening created here, right? So now I can start building my window and door frame around the opening. Because as we're going to talk about the next couple of weeks, we build our families from the outside in, especially doors and windows. We start with the opening in the wall that we've created, and then we put in our frame, and then we put in our door. Or maybe we put in our exterior frame on the window, and then we put in a glass, and then we put in a window frame, and then the glass inside an operable window frame. So it's always from the outside in. So now that we've got the perimeter sorted, we can start building the geometry of this door. What you're actually seeing there, this U-shaped piece, is a useless piece of door trim that shows up in the template. I always delete it and keep going. So there's my opening. So now I can put my door frame inside my opening here. So there's my door frame on 3 sides. And then, once my door frame is in, I can add my window frame for my side light. And then I can put in my glass for the side light. And then I can model my door inside my door frame. So get that opening sorted out if there's going to be a custom opening. And then you can proceed with the rest of the modeling. Then the next step, and maybe even before you create the openings, is to decide what you need for reference planes for your family. Now, if you folks remember from the intro course, we made a fixed window that had 3 horizontal dividers and a single vertical divider. So we had 6 different panes in that window. So what we need to do is, based on the design of our family, figure out the number of reference planes that are going to be needed. So here, I've added this side light. How many extra reference planes do I need to be able to control the geometry of my side light? Well, 2. Now, I don't have a green pen with me, unfortunately, but we're going to add a reference plane here, right at the edge of the opening there. And then we're going to add another reference plane here. So those reference planes will control the width and the height of those side lights. So let's think of some, other examples. So here's a window that's kind of built of several different lights. There's not any framing between these windows. It's kind of all one thing. It would be an unwieldy thing to put into a wall, but let's say this was all one window. So what reference planes are needed? Well, first of all, we need a reference plane for the overall height of this thing. And then we need reference planes here to define the height of these little shoulder windows on the side. Then we need reference planes here for our vertical pieces here. And then I would probably be tempted to have a reference plane here for these Muntin bars. And there will already be a center line reference plane going down the middle of the window, which would deal with this divider up on the window. And maybe another reference plane here just to catch that little decorative divider between those windows. So, you know, wherever you've got a major division of your family, you put a reference plane there. So that's your first order of business. Put those reference planes in elevation. So if you guys were here for the intro class, we did that with that window. We put the reference planes in elevation. So then in plan, if we look at this thing, so what we need in plan to control the window where it sits within the depth of the wall, what I'll do is I'll just expand this so it's a little easier for you folks in the back to see. So we need a reference plane for each side of the window frame and one for the glass. So we need 3 reference planes in plan for the front, back, and glass. And then up here, just based on sort of the layout of the door or window, wherever you've got kind of a major division horizontally or vertically, you need a reference plane in those locations. So setting out your reference planes before you build any geometry. And in fact, you would set out your reference planes before you adjust your opening. So if you need a custom opening, fine. Put your reference planes in first, so that as you need to make changes to your opening to facilitate a bigger side light, you're already ready to go. So in this case here, what I should have done was created those reference planes right off the bat. So here I'll use the reference plane command, and I will add these in here. When you make your reference planes, make sure that they extend past the edges of whatever you're drawing so you can see them. I've seen people who build their families and they're trying to be very tidy. And I'm all for being CDO, right? That's OCD but alphabetized. And that's all good, but the problem is you can't see the reference planes anymore. It makes them hard to work with. So always extend your reference planes so they go past the edges so you know they're there. So now what I would do is, now that those reference planes are in place, I'll select my opening. So here's the thing. When I added those 2 lines in initially, watch what happens when I draw these lines over a reference plane that's already there. You see that padlock that was there but disappeared? That's because I've got chain mode on. Let me turn chain mode off and we'll do it again. Does that mean you have to have chain mode off? No. But if you did have chain mode off, you can see that padlock is there and I can lock it. So now, if that reference plane moves around, so will my opening. Now let's just say here, there's my opening line. And I'm going to draw it there, but I'm not going to hit the padlock. Okay, so now watch what happens here. I'll move this reference plane around. And you can see the openings changing there. It's getting bigger or smaller based on wherever I drag that to. But look at this. The opening changed even though that particular pink sketch line, if you will recall, wasn't locked to the reference plane. So if I just hover, tab to get the opening, and then I think I could double click it. Yep. So this particular sketch line here, this one has been locked. Didn't I lock it? I thought I had. Oh. Maybe I didn't. Anyway. The bottom line is that if a reference plane goes in first and then you draw something over top of it later, even if it's not locked, usually that geometry will still move. It's still best practices to lock it, as you see that I'm doing here. So you can use the align command, right? So these lines here, even if they're, right, if I want to get them in place after I've drawn them, we're going to talk about constraints some more. Well, this isn't going to be the first time that you'll see it. But using the align command, you pick your reference planes first, and then you pick the sketch lines of the geometry that you're creating, and we'll mostly be working with extrusions. And after we've done that alignment process, we lock the sketch lines of this geometry to the reference planes that are already there. So, right, reference planes first. Now, getting organized in 3 dimensions. Creating reference planes that will control your geometry in both X, Y, and Z. Naming the reference planes as needed. So in plan here, so if you folks want to go to the plan view, there are some reference planes that are already here for each side of the wall and for the center line of the wall. Those aren't going to help you for making your windows and doors. You've got to add your own so that you can control where your door or window frame sits within the depth of the wall. You want to be able to control where it sits front to back within the wall. So you can see there's your exterior side. So here we would draw 2 reference planes for the front face of the window frame and then for the back face of the door frame, the door frame. And so it says here, after those reference planes have been created, we click on those reference planes and we give them a name. So here, let's call it frame. So a reference plane that's been named can be used as a starting point for modeling operations. We'll see that shortly. As it says in the notes, note the origin feature and closure feature. Now, any reference plane in a door or window that runs parallel to the wall, parallel. So we're looking at the first bullet point on the bottom of page 5 under getting organized in 3 dimensions, rather the second bullet point after name the reference planes. 2 features. Origin, here. So I've got that reference plane selected. There's the origin feature. There's the wall closure feature. Now in your family, 2 of the reference planes will have the origin feature checked. There they are. One running horizontally, one running vertically. Where those 2 reference planes that have that checkbox checked intersect, that's going to be the insertion point of that mouse when you use it in your project. These 2 planes where they intersect is going to be at your cursor when you insert that family. So generally speaking, that's already set up for you. If you wanted to change the insertion point from being at the center to being at the side, you could uncheck the origin point for the center reference plane and turn it on for the one at the side. Up to you. So you have to have 1 horizontal and 1 vertical reference plane where they intersect, origin checked, and that will be your insertion point. The closure feature. So again, the closure feature is for 2 reference planes that are parallel to the wall. You turn it on for the inside face of the frame and for the outside face of the frame. You turn it on for a pair of reference planes. And what happens is that when you use this window or door in the project, the outermost reference planes for your frame, the materials in your walls will come around and wrap the corner and terminate against those reference planes. And you need 2 of them that have that closure feature checked so that your interior finishes will stop at the inside edge of your frame, and so that your outside finishes will turn the corner and terminate against that frame. So you need that closure feature turned on for 2 reference planes. Okay, so then the other things that we're going to be doing is we're going to be adding dimensions and in between the reference planes, and then we're going to label them. We'll see that later. And then we'll add 3D geometry and adjust their visibility settings such as we were showing earlier. That's it for page 5. Over to page 6. Now, you guys should all know what the difference between an instance parameter and a type parameter is. If you click on a dimension, so if you go back to the plan view of your door family here, and you look up here on the options bar, when you've got a dimension selected in a family, right up in the top on the ribbon there'll be a checkbox for the instance parameters setting. And so what that means is, if it is checked, is that this particular parameter right here, frame projection exterior, will be shown to a user as soon as they click on the door. They won't have to hit edit type to change its value. So you're like, well, what does that mean? It would mean every single door could have its own unique value of the frame projection on the exterior of the door. It's like, why would you do that? You're right, you wouldn't. But let me tell you a little story about a builder who built a house while smoking a lot of weed. I'm not joking, because this is Hornby Island. If you guys know, Hornby Island is off the coast of Vancouver Island. There's a lot of draft dodgers there, and they were smoking pot well before it was legal. We did a set of as-built drawings for a local design builder who was, I think he was an architect from the States who dodged the Vietnam War draft and came to Hornby Island and built one of the most crazy, amazing houses I've ever seen. So what we wanted to do was document this guy's what he'd done in this house. And he had sort of like it was a communal thing. So he had a bunch of bedrooms that were along a corridor in this house. And he built all the doors himself. He built all the door frames. None of them were the same size. They're all different sizes because he built them himself, and he was, you know. So we did it in Revit. And what we discovered was that each one of the side lights here, so let's use SW, the side light width, each one of them had a different value. Every single one of the doors. There's about 8 of them in this house. So when we were building the door family to use to populate into this project, so here I'm putting in a dimension, and I'm going to give it a label so it'll be seen as a parameter in the project. Again, just keep your eyes on the screen. You'll do this yourself. Up at the top of the screen, when you have a dimension selected, there's this little button here that will allow you to add a name, a label to a dimension. And so what we did is we made it an instance parameter. Why? So that every time every time you put one of these doors into the plan in this project, side light width as an instance parameter would be there immediately available to you when you hit the door and saw the properties palette. You did not have to hit edit type to change the side light width because it's an instance parameter. Every single door instance can have its own unique value of side light width without having to make a new door type. That's the big deal with instance parameters. And so now, when this dimension is selected, the instance parameter is checked. So that's what an instance parameter does. Okay, levels of detail, page 6. So we've talked about the different levels of detail that come with Revit, coarse, medium, and fine. We've showed how we can take particular geometries inside a family, and if we click visibility settings, we can determine whether this geometry shows up at all 3 levels of detail or just at certain levels of detail. So that's a consideration that will come in later. Now as we start modeling, how do we build a family? What kind of tools do we have to build our families? Go to the Create tab and have a look at the tools that are there. We're going to talk about these tools here in a minute. If I have the choice, I'll always build my families using extrusions. So have a look at that window picture there, middle screenshot, page 6. I could build a window out of a sweep and sweep a rectangle around the opening. But it's actually, if I create an extrusion in elevation, so you can see there 2 rectangles offset from each other, extrude that in elevation, and that creates my window frame. I once ran into somebody who made all their window families, but they made them in plan. You're like, okay, how'd that work? So what they did, they made the window frame in plan. So they had one extrusion at the bottom, which was the stick at the bottom of the frame, so that was extrusion number 1. And then they did another extrusion, like this, on the sides. Right? And then they did the other extrusion here, so there's a 3rd extrusion going up on the side. Extrusion number 3. And then finally their final extrusion at the top. So they built this window frame out of like 1, 2, 3, 4 extrusions. And I was like, why don't you just build it out of a single extrusion in elevation? And you can see there was this epiphany moment in that person's head and their eyes. And of course then there was the, oh fuck. Yeah. So anyway. Extrusions, they are nice and easy to deal with. Over the next page, and we'll see some of these there. We did the sweeps last week with the bars. You folks remember the 3 bars that we swept around the desk? The blends, you folks have seen that already. A revolve, we'll show that a little bit later. Something like a door handle. So here, just watch on the screen here, folks. I'll do a demonstration of a revolve. The important thing with a revolve is whether the axis of revolution is vertical or horizontal. So if I draw my revolve in elevation, my axis of revolution is going to be vertical. So here I'm making a donut. So there's a 2 process. You draw the boundary. So here I'm building a donut in elevation. My axis line will be vertical, so my donut's going to spin around the axis line. So there's my donut right there. Now if I'm in plan, so there's my donut's here somewhere. Where did my donut go? It's not being cut by the cut plane. So here if I create the revolve in plan, so first you draw your axis line. So it's going to spin around that blue line. And if I want to do something like a doorknob, to deal with your your boundary lines, is that just like a floor object or a roof object, the pink lines must go all the way around. So there's my axis line, the blue line. If I'm drawing a round doorknob, I have to draw the center of that doorknob right along the blue axis. The sketch cannot cross over the line of rotation. So if you have something like this, you folks can see, now the Revolve is revolving within itself, and Revit won't like that. So as long as the geometry that you draw with the pink lines does not cross over the blue line, you're going to get what you're asking for. So there's our, obviously too large of a doorknob. Sorry here, it's just the scale of this view is there. So depending on what kind of a view that you're in, your revolve axis depends on the view that you use to start with. I'm going to skip the discussion on swept blends here. We're going to move on to talking about and building our own geometry here. So the other important dialog box here, along with family category, which admittedly you folks won't use very often, the family types dialog box on the bottom of page 7 that we're talking about next, which is this one right here on the Create tab. It's got the 4 blue boxes on it. This is family types. Go and look at that dialog box right now. Super important dialog box. The first thing to mention about the family types dialog box is that it has this dialog box has the wrong name. What the family types dialog box is really about it's a parameter editor. What we use this dialog box to do is to create, rename, and change the value of parameters in your family. So this dialog box is where you can try different dimensional values that different dimensional values of your family right now, changing its size before you use it in the project, and make sure everything works. So family types is a parameter editor. So why, in the name of all that's good, is Autodesk calling it family types? Because Autodesk thinks that you all have clairvoyance. Autodesk thinks that in the future, after you've built your window family, you're going to think to yourself, I wonder what all the different sizes of this family my team will need in the future. So you might make a 3068, and you might make a 3070, you might make a 2670, and so on. Because here in the family types dialog box, you can make different family types, i.e. different sizes of a family, so that when you save it, all those sizes are in here so people can use them. Never happens. What happens? Nobody bothers making any family types. So if I make a new door and I load it into a project without having created a type, when you guys look at it and it's loaded, it'll have the same type name that matches the name of the family. And who knows what size it is? Because it doesn't matter. Because whatever somebody says is the height and width, they'll, oh, 3070, I need a 2668. So they'll go over here to edit type, and they'll hit duplicate, and I'll make a 2668 door. So do you need to pre-make the family types in your family? No. Just make one, save it, good to go. So family types isn't actually used for making family types. It's used so we can modify the values and rename values of, rename our parameter names if we spell them wrong. So in this dialog box, if you put your cursor in any one of the rows here, you can see down at the bottom there's a pencil icon, so you can rename the parameter if you spell it wrong. You can change it to a different kind of parameter, whether it's a type or an instance parameter. So if you're like, you know what, I want this to be a type parameter after all. Cool. Go into family types, click in the row where the parameter is, hit the pencil icon at the bottom to modify it, and change it to whatever you want it to be. You will notice that if it is an instance parameter, Revit puts in brackets default after the parameter name. It's just warning you that that's the default value of that parameter name, and people can change it quite easily. Inside the family types dialog box, you can also create a new parameter from scratch if you wanted to. Let's go over the page and talk about the different kinds of parameters you can get in a family. So here is the create a new parameter. So in the bottom of family type, second button from the left at the bottom. Here's the dialog box where you can make a new parameter that your family might use. Here under type, if I hit the drop down, and if you folks do that, you're going to see a lot of the different parameters listed in this table. The most common kind of parameter that's used in a family, length. The length parameter is what makes your family's stretch. The second most common parameter is the material parameter, third from the bottom. This allows you to change what that part of your family looks like when you render it. So length and material, by far the most common family parameters that we make. And I'm not even going to talk about the rest, because you guys are already into information overload, and you're putting on a really good show, but you guys are like done. I can feel it. It's like too much information already. So instead, we'll just do it by practice here, and everything will kind of make sense as we go. I'm even going to skip the business on reporting parameters here for the moment. Now we're going to move on to subcategories. Now, with doors, they have like sub-layers, right? There's a layer for the frame, there's a layer for the leaf, there's a layer for the trim around the outside, but Revit doesn't have layers, right? Revit has categories. So in your family, if you folks go to Manage and then over to Object Styles, remember that in a project we use Object Styles to control our line weights. Object Styles in a project is where we control our line weights. But in a family, it allows us to look at the different subcategories of our family. And what these subcategories are for predominantly is to control the line weights of the different parts of our door. You can see that there is a projection row, column rather, and there is a cut column, projection column, cut column. So for things like the glass, we can control the line weight of the glass when shown cut and plan independently of the door leaf. Now, why should this matter? So I'm just going to show you here. Here's my door frame. Here's my door leaf, and I'm giving them all sort of like a line weight of 3. Here's my side light. And typically when we model the glass that we use in a door, we'll make the two lines about an inch apart. Now what's going to happen is that glass, when you see it in plan, those two lines that are an inch apart can end up reading like one heavy line, and like really heavy, like a 1 millimeter wide line in your plan. That's not so good. So what we're going to do, or what you can do, is you can decide to make your glass, when cut in plan, a little bit lighter, like a line weight of 2. And what that would allow us to do is to have those two pieces of glass in there, but because the line weights are a little bit lighter now, it's going to read more nicely when you see them in plan. That's the purpose of subcategories. You can turn them on and off independently, and you can control their line weights independently. So you'll see that there is a subcategory for the plan swing, that is the arc that's drawn in our plans, and for the door panel. So i.e. you can see here the plan swing is always a light line weight, and our door panel has a sort of a medium line weight. So it means the door swing always gets a nice light line weight. So subcategories are part of the process of designing a family. So that's why we have those subcategories. So what we're going to do now is we're going to go through the process of creating a window where the frame, we're going to have two frames. One, that's an extrusion, that's a very basic geometry. And one that is a sweep that's at a different level of detail. So over the next few pages here, if you folks want to, bottom of page 8, you're going to use that splayed opening family that we talked about. And I'll let you folks go through the exercise there. And in about 10 minutes, I will jump in with you.